to determine it is connected to home network or foreign network. We have IRDP protocol, right? IRDP protocol advertisements carry mobile IP extensions that specify whether an agent is a home agent or foreign agent or both. Or both. We have here care of address, means when mobile node comes into the foreign network, it will get assigned by the one address. That one we call it as a care of address. And this protocol provides the type of service such as reverse tunneling, generic routing encapsulation, the allowed registration lifetime, roaming period for visiting mobile nodes. These are all parameters are exchanging between the nodes. Through IRDP protocol only it's happening. Here we have one more chance, like rather waiting for home agent and foreign agent advertisements, mobile node itself can advertise for itself. I have entered into the foreign network. Can you please advertisements to me? Like this, it can start its request. The request forces any agents on the link to immediately send an agent advertisement. If a mobile node determines that it is connected to a foreign network, it acquires a care of address. Two types of care of addresses here we have. Care of address acquired from a foreign agent, and that is one thing. Care of address acquired from the foreign agent, that is first one. And the second one is care of address is got assigned by the same home agent. Same home network itself, the other home agent, means we can say that is corresponding node. It is care of address acquired from a foreign agent. The IP address can share the address with the mobile nodes. If it is at foreign agent, if it is at foreign network, that mobile node IP address can share with the can share with that IP address with the all the mobile equipments. If it is co-located care of address, for mobile node only one IP address will use. Here one restriction, this is one restriction. And when the mobile node hears a foreign agent advertisement and it detects that it moved outside of the home network, it begins registration. Then registration process will start here. Just we will see here registration process. Here we can see that agent advertisement, registration, advertisements. Okay. And how that packet structure, agent advertisement packet structure is here, that header, type, code, checksum, addresses, and that timestamp value, lifetime, we can say lifetime. These are all values we can see. This is the data inside of that one. Type, length, sequence number, registration. And if we see registration process, the first step here it's happening is the mobile node is configured with the IP address and mobility security allocation. The mobile node is configured with the IP addresses and mobility security association, which includes the shared key of its home agent. In addition, the mobile node is configured with either its home IP address or another user identifier, such as network access identifier. First step in registration process is mobile node is configured with the home IP address and shared key. These type of configurations all it's have, and network access identifier, these type of parameters mobile node have. And the mobile node uses this information along with the information that it learns from the foreign agent advertisement to inform a mobile IP registration request. And some more parameters has learned from the foreign network, like like that information it will keep into the mobile IP request to its foreign agent. Through foreign agent, it will send that registration request to home agent. Either through mobile node sends the registration request to its home agent, either through the foreign agent or directly if it is using a co-located care of address and is not required registered through the foreign agent. If it is directly the care of address is allocated by the home agent, means home agent with the help of corresponding node, that is not required to send through the foreign agent. If the register request is sent through the foreign agent checks the validity of the registration request. The requested tunnel encapsulation is available and reverse tunnel is supported or not. In that registration request itself, that tunneling and reverse tunneling is supporting or not, those type of parameters, all it will check. If the registration request is valid, means with respect to that timestamp, that request is valid. The foreign agent adds visiting mobile node to its list before the foreign agent adds visiting mobile node to its list before relaying request to the home agent. Means in that database, in that table, it's adding that request before relaying that request to the home agent. If the registration request is not valid, the foreign agent sends a registration reply with appropriate error code to the mobile node. The home agent checks the validity of the registration request. Here also again, the home agent checks the validity of the registration request, which includes authentication of mobile node. If the registration request is valid at home agent, the home agent creates a mobility binding mobile node with its care of address, a tunnel care of address, and routing entry for forwarding packets to the home address to the tunnel. If the registration request is not by sending a registration reply with an appropriate error code. Here shortly if we say mobile node is sending registration request to foreign agent and it's checking whether it's valid or not, and it's adding in its table, and foreign agent relaying that message to home agent, and home agent also same, it's checking that registration request is valid or not, and it's adding in its database, and binding is happening and it's replying, registration replying is happening, and that registration reply through foreign agent, finally it will go to mobile node. Finally mobile node accepts the registration reply message. Finally mobile node accepts the registration reply message. The mobile node is confirmed that the mobility agents are aware of its roaming. The mobile node comes to know that the mobility agents are aware about its roaming. From home agent, tunnel is established to mobile node. From mobile node, tunnel is established to foreign node. In case where the registration is denied because of time mismatch, the mobile node makes the necessary adjustment based on home agent timestamp and attempts to registration against. Then we can say here a successful mobile IP registration setup is happening through this routing mechanism for transferring packets to and from the mobile node as it roams. Finally, this is the mobile IP registration header. Encapsulation, just we will discuss 2-3 points about the encapsulation. Before going to encapsulation, this tunneling we'll see. The mobile node sends packets using its home IP addresses and it is roaming to foreign network. Home agent to tunnel will establish with the foreign agent, and from foreign agent that tunnel will be established to mobile node. Means from home packets transmission has started, means it's doing encapsulation and it's sending to foreign agent, and foreign agent will decapsulate the packets. Same thing will happen at the foreign agent while sending to the destination mobile node. Here we are using generic routing encapsulation. It's a optional encapsulation. We can use generic routing encapsulation also. Here we are having the original IP header and original data. We are just hiding that everything with the new IP header, that is mobile IP header. This is IP in IP encapsulation, means mobile IP header. This is the actual IP header and this is data. Like this encapsulation will happen. Minimal encapsulation means repetition of identical fields, means redundant data, time to leave, IHL, version, type of services. These ones avoids repetition of identical fields. It's a minimal encapsulation. It's the second one. Generic routing encapsulation. Here we are having the original header and original data. This is with GRE header. This is generic routing header and this is mobile IP header. It's an optional one. Means reverse tunneling from source mobile node, home agent and foreign agent destination mobile node. That forwarding tunneling will happen and reverse tunneling also will happen for exchanging the packets. We take 5 minutes break. I'm getting cough also. Just 5 minutes we'll take break and we'll continue, please. Hi all. Hi. Okay, we'll continue. Just we will discuss about the new topics like route optimization and DSCP, Dynamic Host Control Protocol. These two we will discuss now. It's audible, right? Yeah. And oops. Route optimization is very important while we are transmitting packets from source. While we are transmitting packets from source mobile node to the destination mobile node. Here we have like a home agent is nothing but a one router, and foreign agent we have, and it's nothing but a one router. Uh, while transmitting packets from one mobile node 1 to mobile node 2, we have many home agents and many foreign agents. Every home agents wise and foreign agents wise, it's important to maintain the best route to deliver the packets. This is all comes under the route optimization. Here, uh, from mobile node 1 to mobile node 2, while we are delivering packets by using the care of address, uh, just we are always configuring the next router information into the source agent. Then we are trying to deliver packets as per those configurations. In this way, we can achieve what is the best path to send the packets from mobile node 1 to mobile node 2. This is all comes under the route optimization. Here we can see about the route optimization. Routing examples for an ad hoc network means by finding best path to transfer the packets from mobile node 1 to mobile node 2 by using all the configurations between home agent and foreign agent to deliver the packets. It comes under the route optimization. Now, the one more protocol which is very important protocol, that is DSCP protocol. While roaming time from home network to foreign network, when it roams for that particular destination mobile node, it will allocate the IP address through DHCP protocol only. That one we'll see now. This is dynamic host configuration protocol. Here it works as a client and server architecture. How exactly it works? When a mobile node visits a foreign network, then it gets a new IP address known as care of address. We know all when a mobile node visits a foreign network, then it gets a new IP address known as care of address. This is by happening by agent discovery process and advertisement process. And also a co-located care of address is obtained by the dynamic host configuration protocol. This care of address, we are always saying about the care of address, COA. It's always obtaining by the DHCP, dynamic host configuration protocol. And if we see next points, we consider one mobile computer. We consider one mobile node that visits another network which has a separate domain name, server identity on the network, and functions as a subnet on the internet. The computer gets a new IP address in this case too. And the server provides a dynamic IP address, subnet masks, and ARP and RARP characteristics. ARP protocol, RARP characteristics, what are the characteristics are need while entering into the foreign network. The server provides a dynamic IP address with these protocols to enable that mobile node to transmit and receive IP packets at the new IP address from the internet via that subnet mask. And the server has its own IP address to provide connectivity to the internet. Dynamic host configuration protocol is a protocol to dynamically provide new IP addresses and subnet masks for the visiting computer so that it can use the server and subnet router at the place being visited. Means it's here DHCP is playing main role for allocating the IP addresses for the visiting mobile node. We can say that is DHCP client, which is allocating that IP address. That one we are calling it as a DHCP server. It's a DHCP server and DHCP client. DHCP server is allocating IP address to the DHCP client. Here we have set of messages. We will see what is DHCP discover message, what is DHCP offer, and DHCP request and DHCP pack. These four kind of messages we have. We will see one by one what is happening here. DHCP is a protocol to dynamically provide new IP addresses and set subnet masks for the visiting mobile nodes so that it can use the server and subnet router at the place of being visited. Any software in an agent, example foreign agent visiting a mobile node or device software for connecting to the network can have a software component called the DHCP client. Means that foreign agent visiting a mobile node or device software for connecting to the network can have a software component. This mobile node we are calling it as a DHCP client, and the DHCP client protocol communicates with the server. What are the steps we have here, or we can see in those steps exactly what is happening between DHCP server and DHCP client. First step is the DHCP client is an agent, or we can say mobile node or computer. It's a laptop, or we can say discover. It discover the request known as DHCP discover directly or through a DHCP relay agent to the server. First DHCP client is sending this DHCP discover message to the server, and from there this DHCP server will give the first DHCP client is sending DHCP discover message to the DHCP server, and DHCP server is giving a DHCP offer message to the DHCP client. In DHCP offer, it's giving set of configurations. So what is the IP address to allocate to the DHCP client? These are this type of configurations. IP address allocation configurations is providing to the DHCP client. Here we can say a subnet may have a number of DHCP servers. For this reason, the request is broadcasted to several servers. A DHCP server may be part of the mobile node. Means here intention is to tell DHCP server will support to many DHCP clients. And here the next step is DHCP server listening to the discover request finds the configuration which can be offered to the client, and servers sends the configuration parameters including an IP address and presently in use, not in presently use. At the subnet, the configuration parameters are in the DHCP offer for the offered configuration, and the server will send the first client is initiating the DHCP client is initiating the DHCP discover message, and server is initiating the DHCP offer message. In this, it's giving the IP address which is allocated to this DHCP client, which is not in use also. Presently, it's not in use. It's going to allocate to the DHCP client. That configurations will come into the DHCP offer. Through DHCP discover is asking the request to DHCP. By DHCP offer, it's providing the IP address, and the DHCP client can reject the offer from a server or servers. When DHCP offers from all the servers are rejected, the client repeats the steps from the beginning. If the client is rejecting the DHCP offer message from all the servers, then it will try to initiate once again DHCP discover message, and that server will send the DHCP offer message. The client replies to the server through a DHCP request message to each server. The option it will keep reject is set in each reply to those DHCP server to which the client reply is reject. The option select is set for those servers to which the client is select. And here by keeping select or reject, it will give the DHCP request message to the particular servers. The selected DHCP server creates and manages bindings. If particular a server got select option in the DHCP request message, then that particular server will do like that particular server will do like that particular server the selected DHCP server creates and manages binding. Now the second step will start the server side. It will binding that IP addresses, and it will manage collection of configuration parameters, including at least one IP address which is associated with and binds to the DHCP client. DHCP server also sets a time interval during which the offered IP address will be valid for the DHCP client computer. The required interval can vary depending upon the likely internet connection. Those timestamp values it will keep, and it will try to send, it will bind, and it will try to give the message. And the DHCP server confirms the binding through a message. It sends a DHCP pack after creating the binding. After creating when the DHCP computer leaves the subnet, it sends DHCP release message. After utilization of client that service, if it wants to leave the subnet, then it will send the DHCP release message to the DHCP server. In case the client does not send DHCP release within a specified time interval, the server frees the created binding. And the server and client also use the authentication protocols before considering the DHCP discover from a client and before accepting the DHCP offer respectively. And it's a process like while allocation of IP addresses to the mobile UEs. Sorry, mobile nodes. This is the importance of dynamic host configuration protocol. Server renewal of configurations, many options are there, while packet exchanging, the packet headers. DHCP acknowledgement. Here we don't have anywhere DHCP acknowledgement. Here we have DHCP request message and DHCP pack message. Sorry, DHCP acknowledgement message. I'm just considering it as a pack. This DHCP ACK purpose is client is giving request, right? Client replies to the server through a DHCP request message to each server, means whether it's a select or reject, like that it will keep and it will send that message. The selected DHCP server creates and manages the bindings, means the DHCP servers confirms the binding through a message. It sends DHCP acknowledgement after creating the binding, means it's coming that binding, it's doing that binding, that IP address with the configurations, and in that those are all the IP addresses, everything that binding is sending in the DHCP acknowledgement message. That is the purpose of DHCP. Okay, till now we have discussed the topics are like IP address importance in the mobile IP networking, and how exactly mobile IP works, and how packet delivery is happening while roaming mobile node from home networking to foreign network, and how we are maintaining the handover while roaming time from home network to foreign network and foreign network to home network, and location management, how we are maintaining location management by giving this advertisement, agent advertisement process. These are, and registration is also have the step in mobile networking layers, and tunneling, forward tunneling and reverse tunneling also we have here, and encapsulation. While doing tunneling, how we are encapsulating forwarding side, how we are decapsulating at the receiving side, these type of topics we have covered. And route optimization, what is the best and route optimization, what is the best path to send from source mobile node to the destination mobile node, this packet delivering, what is the best route, this route optimization we have discussed, and DHCP, dynamic host configuration protocol, how to allocate the IP addresses while roaming mobile nodes by considering the DHCP client and server architecture, how exactly is happening, these all messages like DHCP discover message, DHCP offer message, and DHCP request message, and DHCP acknowledgement message, and why after utilizing this client, these services, how it's releasing from the subnet, and exactly what is happening. All these topics we have discussed up to now. Any questions? Miss, till now we have completed about the mobile IP networking layer, mobile IP wise, mobile IP, how it's working exactly in the networking layer. That topic we have completed. We have to discuss about the transport layer or mobile IP wise in transport layer. What are the functionalities present? This is the next topic we are going to cover. In next session, everything is about the transport layer, mobile IP working wise in transport layer. What happening? That is our next session. If you have any questions, please ask me. Just I will discuss with you now itself. With this, I am concluding the session for mobile IP networking with network layer. Encapsulation is nothing but our original IP header is there, right? And our actual IP header and IP data packet. We are hiding this one with our mobile IP header. Here we are having generic routing encapsulation and IP in and IP in IP encapsulation, means two types of mechanisms we have. Just we are encapsulating original IP header packet with our mobile IP header. That is encapsulation. At receiving end, we will decode first mobile IP packet and we will try to get the actual IP header. This is encapsulation and decapsulation. That is encapsulation. Thank you. Thank you to all.